Okay, quiz 3. Okay, metal MC. So the first one, when heating calcium nitrate, we decompose according to following equations. Okay, sample you have like 82 gram. Calcium nitrate is strongly heated with a mass of oxygen. Okay, so this one should be pretty easy. So first of all, you have to calculate number of mole of calcium nitrate. So you have like 82 over 40.1 plus 14 plus 16 times 3. So this one times 2 because you have like 2 calcium nitrate. So this one is the number of mole calcium nitrate, and then you divide it by 2 times 1, 2, 1, okay? And then this one will be the number of mole of O2. So you find the mass of it, so therefore you just times 16 times 2 times the molar mass will be all right. Okay, so this one is mm of O2. So the answer for this one, okay, should be A. Or number 2, which of the following experiment will reaction take place? So aluminium with water. Okay, do remember. Okay, we have 鉀、鈉、鈣、鎂、鋁、砷、鐵、鉛、銅. Okay, so these 3 are with the cold water. So these 4 are with steam. For magnesium can be hot water, right? So this one react with water, aluminium should have no reaction at all. When then copper to react with dilute sulfuric acid, remember this one for the acid can react all the way to Pb acid, okay. But for Cu, okay, normally it have no reaction, okay. Remember this one is not reactive enough. So therefore not likely to have reaction. Okay, and then mercury to react with dilute hydrochloric acid. Mercury is even lower, so not possible. Okay, and the last one, zinc in air. So this one is correct, okay, because we just burn the metal, okay, and then we'll just heat it up, okay, and then will become zinc oxide. So the answer for the second one is okay. And then number 3, a relative atomic mass of X, okay, is 35.5. An oxide contain 18.4. So you see percentage here. Okay, we are going to find a ratio of X to O. That means you are calculating empirical formula for this. Okay, so what you do to have is X right there. Okay, and O here. Okay, let the things be 100%, then it will be 18.4. Okay, while the other one will be 81.6. okay, so for number of mole you divide this one by 35.5, this one by 16. Okay, so the answer for this one will be 2.30, things like that. Okay, while the other one will be 1.15. Okay, so 1.15, you just divided this one by 1.15, and this one will be 2, this one will be 1. So will be X to O. Ratio of X to O will be answer C. Okay, and then question number 4. Consider the following reactions: ammonia and copper to oxide. So this one will be 6.8 gram ammonia react with 35.8 gram of copper to oxide. So 6.8 gram divided by 14 plus 1 times 3. Okay, 6.8. So this one will be, so this one will be 0.4 mole, while the other one 35.8 divided by 63.5. So this one is copper to oxide. Copper to oxide should be CuO plus 16. Okay, so this one will be 0.45 mole. Okay, so this the ratio is 2 to 3. Okay, so if we have like 0.4, so 0.4 mole of NH3, so 0.4 divided by 2 times 3, then it will be 0.6 mole. But now what we have is only 0.45, so this one is a limited reagent. So this is limited reagent. So we use this one to find out N2. So we have 0.45 divided by 3 times 1. okay, and then we find this is number of mole of N2, and then you have multiplied N2 by 2, okay, the N by 2, okay, that will be the molar mass of it. So the answer for this one will be 4.2. Answer number 4 will be boy. Okay, so for the question behind, okay, it's more difficult. Okay, so have a look. Which of foreign contains the same number of atoms? Okay, we are talking about number of atoms. Okay, number, not number of mole. So you have like, for sulfur dioxide is SO2. So we have like 6.41 over 32.1 plus 16 times 2. So this one is a number of mole, right? So you times L and then atoms. Okay, so we have 3 atoms in it, so you times 3. So this will be the number of atoms that we are having. Okay, then next, okay, what you need to do, okay, is to find out each of them. Whoa, that's a lot of things to do. Okay, anyway, A will be 1.7 over 14 times 3, and then you have 4 times L. Okay, actually L is not very important, but anyway. Okay, and then this one is 44, right? Okay, because it's CO2. Okay, and then CO2 you have 3 atoms in it, so you times 3. Okay, and then C will be 3.65 over 35.1 plus 1. Okay, and you got 2 particles there. 2 atoms there, okay, and then D will be 4.6 over 14 plus 16 times 2. So this one we will have like NO2, we have 3 in it, okay. So you just do the math and then find out which one will be the answer, okay. So the answer for this one is dot. Okay, so question number 6 is very important and interesting, I think. Okay, PQRS represent 4 different compounds. Okay, P and Q react to form the following equation: P grams of P, and then Q gram of Q. Okay, give R gram of R and S gram of S. So what is the value of S? Okay, so this one is pretty easy. To be honest, okay, before you learn chemistry, you will be better to solve these questions. Okay, so the only concept that you need is conservation of mass. How many mass you put in it, how many mass you got at the end. So pretty easy. It's P plus Q. That is the mass of the reactant, will equals to the mass of the product. So S will be P plus Q minus R. Okay, worth doing. This question is very, very good, okay, and important. Okay, and then question 7. Relative atomic mass of X is 39.7. Okay, 4.53 gram of X are allowed to react with excess oxygen. So X react with the oxygen and then give out something like this. I don't know what is the ratio of this. So 6.1 gram of oxide. So this one is talking about this. 6.1 gram, okay? Obtain what is the empirical formula, okay? So this one is pretty simple, because you know this one is 4.53 gram already. So XO, this one is 4.53, then this one will be 6.1 minus 4.53. So this one you just divide by 16, this one divide by 69.7, okay, and then you can blah solve the whole thing, okay. So the answer for this one is boy, okay, pretty easy. I'm not going to solve it with you. So chemical formula of the 2 chlorine oxides, okay, one is Cl2O, one is Cl2O7. Okay, if 1 mole of Cl2O contains an atom, so this one is mole convert to number of atoms. So 2 moles of Cl2O7 would contain. So you have to try to solve it. Okay, first of all, you solve the first one first. Okay, 1 mole of these atoms, okay, of these compounds, okay, contain n atoms. How can you convert it into number of atoms first? So you got number of mole. First of all, you remember the diagram, okay? So you just go through like this. So you have to times L and then times N, right? From number of mole times L times N. So 1 times L and then times N. For Cl2O, we have 3 particles in it, okay? So therefore you times 3. So according to the first statement, it tells you that this number of atoms is N. So pretty easy. L will then be N over 3. Okay? Why I have to do that? Because you find out the second section, this part. okay, with 2 mole. And then we want to find the number of atoms as well. So what you need to do, you do the same thing from number of mole and then find number of atom. So you times L and then times 7 plus 2. So you have 9 right there. So this time, okay, you have like 18L. But 18L, how many N you're talking about? Because the L you don't know, okay? So you convert the L, okay? You substitute this one in it. So you will then have like 18 times N over 3. So this one will then be D, 6N of atoms. Okay? So we just convert the L. Both of them, they got L. Okay? But according to the first equation, you find L equals to N over 3. So you just substitute this concept or you convert all the L in terms of N, then you can find out the number of atoms in it. Okay, so last two. A gardener used a compound that cannot be stored in zinc-plated can and a compound B. So when you see this one, zinc-plated, that means you got zinc. Okay, and they give you some metal salt solution. What concept you can think of? For sure, it must be displacement reaction. Remember, a more reactive metal going to displace a less reactive metal from solution. So which one is going to have displacement reaction? Which metal is less reactive than zinc? Answer is boy. Okay, so KCAMG more reactive than that. So the answer will be boy. Okay, so the last one, different metals drop in water and dilute hydrochloric. Assume that the experimental conditions are the same. So we can compare the initial rate. Which one is faster in generating the hydrogen? Okay, so have a general concept about all these things. So you have like calcium, barium. So calcium here, barium is lower in group. So you got like sodium somewhere here, K somewhere here, okay, and then you got cesium down here as well, okay. So this is the concept of that. Okay, group 1 and group 2. Which one is more reactive? Group 1 is definitely more reactive than group 2. Okay, group 1 is alkaline metal. So group 2 is alkaline earth metal. Okay, so group 2 is less reactive. So the first one, Ca and Ba. Okay, calcium, barium, both of them, they are group 2 element. But we know that the reactivity increased down the group. That means Ba is more reactive. So the first one is wrong. Okay. Second one, cesium and calcium. So cesium is here, calcium is here. So even they're not in the same group, you know that lower is more reactive. So cesium should be more reactive than K. K should be more reactive than calcium because K is group 1, calcium is group 2, and this one is a lower group 1. So therefore B should be correct. Okay, check the rest. Na and Cs. Okay, again, Na is a higher position in the group. Okay, the lower members. So Cs should be more reactive. Okay, so this one is wrong. Last one, where you got zinc and sodium. Hey, obviously you know that sodium is more reactive when you put it in water. They give out a lot of hydrogen. It will be explosive. But zinc will be safe for you to put in HCl. So this one is wrong. Okay, so the last one, the question 10. Okay, the answer should be boy. Okay, should be boy. Okay, so that's all. Okay, bye bye.